Okay, we're working on skill practice 1 from chapter 5, section 3, where we are finding trigonometric function values for non-acute angles. So the first thing you want to do is draw your triangle. We're going to draw our triangle in relation to the horizontal axis. Right here is our angle. This is a right triangle that we've created. And our x and our y's are negative. So we are going to have -5 here, -7 here, and we need to find our r value. And remember that r is equal to the square root of the x value squared plus the y value squared. That's going to be the square root of 25 plus 49, or the square root of 74. Now, 74 is not something that has any perfect squares in it, so we're just going to leave it as the square root of 74. Remember that the sine of theta is equal to y over r. Cosine of theta is x over r. Tangent of theta is y over x. Cosecant of theta is r over y. It's the reciprocal of sine. Secant of theta is r over x. And cotangent of theta is x over y. For the first one, we're going to take 7, but it's negative because we're in the third quadrant. So we have -7 over root 74. And you know, of course, we're going to rationalize that denominator. Nothing's going to simplify though. And so that's going to be -7 root 74 over 74. For cosine, we have our x, which is -5 over the square root of 74. Rationalizing, again, nothing's going to simplify here. That means that cosine of theta is -5 root 74 over 74. And then tangent is a little bit more friendly. It's y over x, or -7 over -5, which simplifies to 7/5. And I'm going to go ahead and do cotangent, which is the reciprocal of that, which is 5/7. We don't need to rationalize the denominator for cosecant and secant because we are putting that square root of 74 in the numerator. The cosecant of theta is going to be root 74 over the y value of -7. You can put the negative out front and call that root 74 over 7, which is negative. Secant is going to be the square root of 74 over -5, which is negative square root 74 over 5. Moving on to skill practice 2, we're going to find the values of sine, cosine, and tangent for the given angles, and these are quadrantial angles because they fall on axes. Drawing our axes, recall for question A that pi over 2 is on the y-axis. And so remember, I did this earlier in the class video, but you've got some point 0, y. The book uses 1 for a y value. You're more than welcome to do that. I'm just going to keep it basic. When you're dealing with this, then this means that r squared is equal to x squared plus y squared, or r is equal to the square root of x is 0 in this case. The distance between this point to the origin is 0, and then we have r squared, or r equals the square root of y squared. And so r equals y in this case. So the sine of theta, which is y over r, we have cosine of theta, which is x over r, and tangent of theta, which is y over x. Y is just a y point, and r, again, we know it's y, so that just winds up being y over y, which simplifies to 1. X is 0 in this case, over r. 0 divided by anything is 0. And then again with tangent, we have y over 0, which is undefined because you cannot divide by 0. For part B, we're dealing with degrees instead of radians. We have 360 degrees, which is a full rotation from the standard position. You start out and you go all the way around. And we're back here at some x value where y is 0. The sine of theta is going to be equal to y over r. Cosine of theta is x over r, and tangent of theta is y over x. I'm just repeating these so that you start to get familiar and start to memorize them. Again, r in this case is going to be the square root of x squared plus y squared, and y is 0 at this case, so r is x when we're dealing with 360. So we have the sine of theta, I'm going to move this. The sine of theta is equal to y, which is 0, over r, that's 0. The cosine is x value over r, well, we know that r is x, that's 1. And then we have 0 divided by the x value, which is 0.